I have this power supply from a Samsung LED TV with part number BN44-003738, and it has a no power fault. Now the first thing I'm going to do is plug it into power. And I'm going to do some voltage checks. So I am in DC mode. I'm going to use my negative lead and I'm going to ground it over here. Now taking a look at this connector CNM801 over here, it says that I should have standby on pin number 16. So that's going to be the bottom row, pin number 2 from the top, and we're getting 0 volts. All right, so we're getting no standby. So next I'm going to measure the filter caps, see if we're getting any power here, and we're not, 0.268 volts. All right, let me go to AC mode, and let's make sure that our power, the AC power, is getting through the fuses. Yep, it is. We're getting 120 volts, so that means these 2 fuses are good and we're getting our power coming in. All right, let's disconnect power. So at this point, we're not even getting power to our filter caps, but our fuses are good, and we can remeasure them in, this is in beep mode, so I get a beep and 0 ohms when I get a short, and a shorted fuse is a good fuse, so these are good. Let's take a look at this fuse over here, also shorted, also shorted. So that's all 4 fuses. So something that I do know is that our filter capacitors are tied to this IC chip over here, which is IC B801, and it doesn't look like it's burnt or damaged. Yeah, let's take a look at the back again here. All right, we're switching over to the microscope to take a closer look, and I'm noticing something here, which is it looks like it's burnt between these 2 pins. So let's see, is this shorted? Are these 2 pins shorted? They are not shorted. Okay, and it looks like this one could be corroded. What is that? I'm not sure. So I'm really not liking the look of this. Let's clean it up real quick. Yeah, so to me it looks like that was a little corrosion right over here. A little corrosion was starting over here, and something definitely happened here where this burnt up. It must have arced or shorted or something. Now it's not shorted with the multimeter. I'm not seeing a 0 ohm resistance. Let's do an actual resistance check here and see what we get. Okay, and it looks like it's open. I'm getting 0 OL, so open loop. So this is highly suspicious. I don't know that this is going to be the end-all be-all repair, but what I do know is if I don't replace this chip, there is a good chance that whatever else we do find that's bad could go bad again, because this chip has had some damage to it. I don't know the extent of it at this moment yet, so let's start with just replacing that chip and see what we get from there. All right, I'm going to use my desolder wick to remove the original solder off the board. All right, and I should be able to just push it through. So this is our replacement. We'll go ahead and feed it through. There it is. Now, when I was using the desolder wick, it looks like I did remove a little bit of the solder from this capacitor, so let's make sure we put some back. Make sure we have good contact there. Let's do a quick clean. We have our new IC installed. I have my multimeter in DC mode. Let's go ahead and plug it in. Let's first check our standby voltage, see if that's come back. Something I didn't mention is I do believe the standby voltage is actually directly linked to this IC chip. So that's part of the reason I wanted to replace it as well. And let's take a look. And our standby is back. We have 5.2 volts. All right. Let's take a look at our filter caps here. Do we have voltage? We have 4.3 volts. Okay. So that's not supposed to be, I mean, it's supposed to be 390, well, 167 if it's off and 390 if it's on. Let's see what this little guy shows. Okay, this one's showing the 167. Right, so it has 2 circuits. Okay, so what that means is we need to power up the board. So these older LED power supplies do not auto turn on like the newer ones do. So we have to give it the command to turn on. On this one, pin 18 is our power on off command. So I'm going to use this jumper to give it some juice from the standby line. So essentially we're jumping that 5 volts from the standby to the power on line. And I just heard it click on. So let's recheck now. We have 300 volts, but it's going down. I don't think I have good contact. I just heard it click again. Okay, and now I have a steady 390 volts. All right, so we have a successful repair. So it looks like that IC was actually the only fault with the board. So we replaced it. Now we have a steady voltage on the filter caps. We have our standby. One more thing I want to do is make sure some of our other output voltages are present. Over here we're supposed to be getting a lot of 12 volt and a 5 volt line. So let's take a look. Do we get our 5 volts? We do have our 5 volt, which is different than the standby. And then our 12 volt is down here, and we do get our 12 volts. All right, we'll disconnect it. We'll discharge our capacitors. All right, it looks like we have another successful repair. If you're interested in sending in your power supply for repair, we'll have links in the video description down below to our website, where we offer a flat rate service with a 1-year warranty. Otherwise, if you like the video, make sure to leave us a like, subscribe for more content, and thank you for watching.